Raspberry Pi. It's a credit card-sized computer that costs around £25, designed to teach young people to program, and is capable of doing all kinds of wonderful things. A free operating system from an SD card. You just plug in a mouse and a keyboard, connect it to a TV or monitor, and you're ready to go. In schools, not only is Raspberry Pi a great way to learn programming skills like science, people using the Pi in a variety of amazing and interesting projects, taking advantage of its size, portability, cost, programmability, and connectability. So whether you want to learn to make games, build robots, with Raspberry Pi, the sky's the limit.
Hi Indiegogo, I'm Jesse.
And I'm Ryan. Last year, we launched PiTop, the world's first Raspberry Pi laptop.
PiTop Seed has a 13.3-inch HD screen and a 180-degree hinge for a wide range of viewing angles. The front-facing acrylic slice gives you easy access to your Raspberry Pi and circuitry.
Not just a 3D printer. Not just a milling machine. Not just a 3D scanner. Introducing Fab Totem Prism. Fab Totem Prism is a new stereolithography 3D printing technology. It's an affordable yet high-quality solution that works without expensive optics. Prints small details on a huge printing volume.
Hello, this is my mini console, and it is powered directly from the GPIOs of the Raspberry Pi. Besides the Raspberry Pi are just some stock electronics, A4988 stepper drivers, nothing that's not standard.
Welcome to the Raspberry Pi. This is a credit card-sized single-board computer developed in the UK to teach basic science in school. The project has been developed by my good friend and part-time genius, Baris Akin. This project cost under $100. What I really want to show you is how it uses a simple USB barcode reader, a Raspberry Pi that costs $50, the USB barcode reader costs $20, and an S-Link HDMI to VGA converter and an old VGA monitor. And I'd really like to show you how this simple configuration is operating in a company that last year turned over 80 million euros. The purpose of the Pi system is to track customer orders in real time. It's linked to a company ERP system which is capable of reading production speeds and the amounts produced. In this instance, cable length. This is via links to a Siemens PLC. It uses only the barcode scanner and requires no mouse or keyboard. Commands are sent using unique barcodes, and it's written in Mono C# and GTK Sharp graphical user interface. Let's just see it in action. The first thing we're going to do, okay, we're getting to the operator. We'll press this down to select which operator we wish. Yashin Ifilti. Next we'll change to the order. Now we're going to choose an exact order using the simple scanner again. As you can see, it's now showing us this is the meters produced and the meters that we hope to produce at the end of it. The order is entirely controlled by the Pi system, using the system simply costing $100.
Scientists in China have unveiled a supercomputer that's twice as powerful as any existing machine. Aside from the Milky Way 2's extraordinary speed, the massive computer is remarkable in a number of other ways, as Tariq Bazley explains.
It's 2 years ahead of schedule, and the Tianhe 2 is quite simply in a class of its own. It's made up of over 3 million processors, the kind of chips you find in a top-end desktop PC, and its computing capacity is massive. Forget about 1 million calculations a second, or even 1 billion calculations, not even 1 trillion and not a quadrillion. No, this computer can do 33.86 quadrillion calculations every second. That's more than twice the number of calculations of the fastest existing supercomputer, Titan. Built at the US's Oak Ridge National Laboratory, it was crowned the world's fastest computer only at the start of this year. But Tianhe 2 stands out in other ways too. Its system design and software are both Chinese-made. It currently makes use of American Intel processors, but Chinese-made chips are expected to replace these in the near future.
Over the years, the Chinese have been producing more of these components, building out a system which is almost totally Chinese in character and nature. And it won't be long, I would predict, before they would replace those Intel chips and make a machine which is totally Chinese.
The extraordinary processing power of supercomputers is put to use doing big number-crunching jobs like weather forecasting. Tianhe 2 is reported to have cost $290 million to build. Tianhe 2's power-hungry circuits chew through 24 megawatts a year, or around $24 million worth of electricity. There are plans for even bigger and faster computers, some with their own power plants. In an increasingly digital world, there's more and more demand from scientists and engineers for processing power, and on a grand scale. And if the past's anything to go by, the technology made for these machines will end up supercharging the next generation of home computers.
Thank you, Jim, and good morning to all of you. Moore's Law is running out. Moore's Law is running out. And you're all familiar with Moore's Law. Here's a graphical representation of it. Moore's Law is the observation that we will be able to double the number of transistors on a wafer of silicon every 18 months or so. And we've taken advantage of that for years, for decades in fact. One of our interns this summer at Wisdom Group, Yvonne Garcia, looked at this chart and she said, you know, Ray, maybe there's a more visual way to communicate Moore's Law. And she went out and found this image that was published in the Washington Post some years ago. This is Moore's Law in a more visual and visceral way, because the functions of all the devices on the top are included in the device on the bottom. And some of you might think the device on the bottom is outdated because it's from 2013, right? So that's Moore's Law. But Moore's Law is running out, the party is coming to an end, and we have to ask ourselves, what are we going to do to increase processing power? One potential answer is parallelism through a device called Parallella. This is a single board computer roughly the size of a credit card or a Raspberry Pi if you experiment with Raspberry Pis, or a BeagleBone Black if you experiment with those. We don't know hardware design at their level. These are some high-end PhD computer engineers, electrical engineers doing amazing things with parallel machines.
At the University of Southampton, we've researched into building systems using cheap parts for a number of years. And we thought that with the Raspberry Pi coming out, that we could put a number of them together and build ourselves a supercomputer, really with an aim to inspire the next generation of scientists and engineers to get into science, engineering and high-performance computing. Lego is a very convenient way for us to put everything together. It was very easy to fit each of the Raspberry Pis into a little Lego frame, and by the time we tried to put 64 of them together, keeping them all in one place would have been kind of impossible without something. Lego is great fun to play with. Each one has a 16GB memory card and then an associated power supply, and then we connected them all together into switches. Each individual computer isn't particularly powerful, about the speed of a Pentium 2 300 MHz. One of the more interesting pieces of power on the machines is the graphics card and the graphics processing. There you're able to get about 24 gigaflops of power. In order to use all of these computers together, you use something called the message passing interface, or MPI. That allows you to send messages from one of the processors into another processor, and then you divide up your tasks so that each computer is working on a small part of a very big problem. The base software starts from a Raspbian image, and then on top of that we're able to use programming languages like Python, which is very popular, and also tools like Scratch, which allows you to animate characters on the screen. One of the nice things about the Raspberry Pi Foundation is they keep improving the performance of that base image, so sometimes as much as 50% between releases. Over the last 10 or 20 years of doing research into these sorts of commodity-based systems, we've seen the price to be able to get something together go from millions of dollars down to hundreds of thousands, tens of thousands of dollars. What you see here is about $4,000 or £2,500. Indeed, if you were to just use 4 of the Raspberry Pis, you'll be down at the hundreds of dollars price point. That means for the first time that it's accessible for schools, colleges to be able to do this kind of thing at home in their own time and have some fun with them. Our overall aim is to inspire and excite people to get into science, to get into engineering, and by starting with something that's cheap and simple, we hope that people can then go on to understand how to do much more complicated things and how to program computers for themselves.